Okay. I felt like for this homework you may want just like a little guidance. So I'm going to just go through a few examples. If you feel like you're good to go, feel free to skip it. So on this first one, it says simplify. Use the distributive property, then combine like terms. So remember like terms, like if you had like an x, it has to have the same, like terms have to have the same variable and exponent for you to combine them. I think that's helpful to remember. So let's start by distributing like we did in that previous one. So 2 times 5 is 10, x times x is x squared. 2 times 3 is 6, and then we also have an x. Okay, let's do the positive 7. So 7 times 5 is 35, and then we still have an x. 7 times 1 is 21. So here, while there are 3 terms that have x's, only these middle 2 ones have the same exponent of just being like 1 or just an x, right? So that 10x squared cannot be combined with them, but those middle 2 give you a 41x. Okay, let's do the same thing down here. So we're distributing the 3x. 3 times 8 is 24. X times x is x squared. 3 times negative 1 is a negative 3. Okay, on this one, I usually do like to distribute the negative 4. Your other option is to subtract and then to do the positive, but I think sometimes then you forget the subtracting, so if we just distribute the negative, we'll just write it as is. So negative 4 times 8 is negative 32x. Negative 4 times 1 is a positive 4, so we're going to add 4. Once again here, the only 2 terms we can combine are the middle 2 because the first one is an x squared, which is a little different than just x. So we'll leave it as 24x squared minus 35x plus 4. So these would be our final answers. Okay. The next one says calculate area and perimeter of each figure. So remember, area is like the inside, and then perimeter is the outside. Think of perimeter as adding, and area as like multiply. Okay, include the correct units. So perimeter, in this case, if there's x's, we would add x 4 times, it would be like x plus x, and then these would mimic it, right? So this would be an x and x, so we added all 4. Since those are all like terms, we just call that 4x. And the perimeter just stays the same units, it's centimeters. Whereas area, we multiply the 2 sides, right? So x times x, and here we'd get x squared. And this is going to be centimeters squared as well. I'm going to change the second example. So rather than it being, I changed it already on your notes, but rather than it being a square, I'm going to make it a rectangle just to spice things up a little bit. So the top will just change, and it's like an x plus 4. But on the side, it's going to be an x plus 1. Okay, so the perimeter, if you want to do like a little shortcut, we could say, actually it's probably just easier to say x plus 4, you could say it's twice that, plus x plus 1, we gotta double those 2 things, right? So x plus 4, x plus 1. So here, if we combine all our x's, we have 4x. If we combine all the numbers, we've got plus 10 inches. Okay, so now it says the area, we're gonna multiply the 2 sides. So we're gonna leave it in parentheses like you see it. And then we're labeling it inches squared. And it says you can leave it as a product. For you honor students, I would say start taking this to the next level, right? We want to think about how we multiply this, and we'll come in on the next assignment, but it doesn't hurt to start thinking about it now. Think about this as what we just did above, right? Think about distributing this x and the 4 to both of those. So I'm going to distribute the x to the x plus 1. And I'm going to distribute the 4 to the x plus 1. So now do what we did above, where we're distributing combined like terms. We get x squared plus x plus 4x plus 1. So we end up with x squared plus 5x plus 1. In this case, inches squared. These are equivalent answers. So either of those work. Okay, last but not least, it says find the GCF. GCF is a fancy word to say greatest common factor. So what are the things they have in common? So notice here like a 7 and a 21. there's a couple different ways you can think about this, but I'd say, okay, what can I divide both of these by? What's the biggest number I can divide both these by? Well, 7 goes into 21, so 7 is actually part of the GCF. Then you look at x squared and x. We're saying, what's the biggest thing I can divide both those by? And there's just 1x. Another way that I sometimes like to think about it as like 7x squared, think about what you multiply it by. It's 7 times x times x. And then 21x, how can we break down 21? I can break it down to 3 and 7 times x. So what do they have in common? They've got 1, 7, and 1x, so 7x is the GCF. Okay, on this next one, so we've got 12, x to the 5th y, and 32, x to the 6th y. So if you want to think about 12, x to the 5th y, and then 32, x to the 6th y, you could say, well, what can I divide both 12 and 32 by? Like, well, 12 doesn't divide by 32, neither does 6, so maybe try some other things. Or you could say, well, 12 I multiply by 3 times 4, and even if you can break up 4 into smaller numbers you want to, so like 2 times 2, whereas 32 I can break up 2 times 16, but 16 I can break into 4 times 4. So maybe I'll break down those 4s into 2 times 2 times 2. It's okay if you write it as bigger numbers, but sometimes you just won't recognize them common. And then they have 1, 2, 3, 4, 5 x's, they're multiplying, times a y, right? Whereas this one has 1, 2, 3, 4, 5, 6 x's and a y. So if you want to think about what they have in common, they got an x, they got 1, 2, 3, 4. Oops, I did not circle that very well. That's where I gotta be careful. Okay, 1. And then we got 1x, 2 x's, 3 x's, 4 x's, 5 x's, and they both have a 2 in common. So you could think of it as 2 times 2 times x times x times x times x times x times y, but that's equivalent to 4x to the 5th y. So let's see in this last one if we can do it without breaking it up so much. So look at 15 and 25. What's the biggest number I could divide both those by? Well, 15 doesn't go into 25, but I know 3 and 5 go into 15, and I can also divide 25 by 5, so 5 is going to be the biggest number. Okay, they both have an a, but one's a and one's a cubed. What's the biggest thing I can divide both of them by? It's just 1a. They both have what is 1b, so that's the biggest thing we can take out of both of them. And then a c squared and a c, I'm only going to be able to pull out 1c. All right, good.